Here's a quick example of how to find the greatest common factor and least common multiple of two numbers. The first job is to factor the two numbers. There's really no way at all of getting around that. So here I have two numbers written in factored form, actually not quite in factored form, so it is important that you factor completely. So this 9 here, we can factor that more. 9 is 3 squared. So to get what I'm about to say to work, you do have to have things factored completely. So now that we have these things factored completely, let's find the greatest common factor of this number and that number. So for greatest common factor, you just have to go down the list prime by prime and pull out the as many factors of each prime as they share, as the two numbers share. Actually, here I see this should be a 2, not a 3. Okay, so looking at our factors of 2, the number on the left has 3 factors of 2. The number on the right has 2 factors of 2. So in common, they have 2 factors of 2. So we'll write down our 2 factors of 2. So that's 2 squared. So what about our next prime factor? Our next prime is 3. They both have factors of 3, but they only have one factor of 3 in common, right? Since the number on the left here only has a single factor of 3, so times 3. And then looking at the 5s, well, the first number has 5 squared, but the second one only has one factor of 5, so we need a factor of 5. So this is all of the factors that these two numbers have in common. So this is the greatest common factor, GCF. So 4 times 3, 12 times 5, 60, turns out. Okay, so what about least common multiple? So to find the least common multiple of these two numbers, we'll start over, we do the same thing, except we, instead of keeping the fewest, we keep the greatest. So, right, for least common multiple, we need to know which is the maximum number of each prime factor. So looking at 2's, this one has 2 cubed, this one has 2 squared. So to get a multiple, we need at least 3 copies of 2. So 2 cubed, and then looking at our 3's, we need at least 2 copies of 3, because this one has a 3 squared, so times 3 squared. And then looking at our 5's, we need at least 2 copies of 5, because this one has a 5 squared, so 5 squared. So this is our least common multiple. And let's see, this is what, 8 times 9 times 25, whatever this turns out to be. So it turns out, so if we call this number, I didn't name this number, but let's call it x, and let's call this one y. So it turns out that the least common multiple of x and y is x times y over the greatest common factor of x and y. So I won't prove that, but you can check that it's true, at least in this case. If you multiply these two numbers and then divide by the greatest common factor, you do in fact get this least common multiple. I don't know if that counts as a shortcut or not, because using this process to build up the least common multiple from the prime factors isn't that time consuming, but I don't know, it's true at least.